Welcome to Router Drawer Basics. This is a videotape from my cabinet making series that focuses on making drawers using router tables and various router bits. There are a number of locking type of joints that you can make, as well as rabbet joints. Many of them are represented right here, and we'll go into detail later in the videotape so that you'll learn more about these. There are a number of different bits that we've used, and I'll just give you a little orientation. Don't get discouraged, you won't need all of these bits. Many of them do the same thing, and we're going to show you the same operation in more than one way. We've got 1/4 inch straight cutting bits, a 1/2 inch dovetailing bit, 1/4 inch round over bit, a 3/16 straight bit, a small beading bit, 2 different drawer corner joint bits, one with a 1/4 inch shank, one with a 1/2 inch straight bit, which is a spiral cut, a glue joint cutter, a couple different round over cutters, a 3/4 inch straight cutter, and a 1/4 and 3/16 inch slotting bit. You wouldn't need all of these. There's many ways of going about it, but I wanted to orient you to the types of bits we're using early on so you'll be aware of those. Now, in addition to cutting the joints, you'll see all of the setups and how to glue these drawers up, so you'll get all this information in the tape. One other thing that I would like to tell you about is some tips on safety and working smart. As you go in, you'll see me working. You'll see that I'll be wearing my goggles and a pair of earmuffs. My hearing's bad enough now. I don't want to have the TV any louder, and I want to protect my eyes from flying chips. I'm going to control my stock as well. I'll be using a push stick, similar to what you see here, or a push block to feed pieces or guide pieces into those router bits. These are good devices to make the operation safer. To keep my hands clear, I'll use something like this barrier guard. This will clamp to the fence, and this will be around the area where the bit is. So it'll be very difficult for me to get my hands into that area. Now, there will be some other devices that I'll think about, and one of them is an auxiliary face for your fence. Many of your router tables will have a very large opening. I put an auxiliary face, or a thinner piece of plywood or solid wood, on there with an opening just as big as the cutter I'm using. If I'm going to be guiding my stock vertically across the face of the cutter, I will make a saddle device such as what you see here to allow me to feed that material vertically. It gives me control, and it protects from tear out because this backs up the cut. So these are some things that you'll see me using, and I would urge you to make these devices before you get so excited about the drawers that you don't think, hey, I need those. So plan that out. Now, one of the first steps is to work on your drawer stock to get it prepared. We'll be working with drawer blank stock that's a 1/2 inch thick, and that's typical of what you find in most cabinet drawers. You'll prepare your stock for desired widths. It isn't a bad idea to make them a little wider. That way, if there's any tear out with the cuts you make, you can joint them or sand them and smooth them up later. 2 of the first cuts that we'll be making will be this groove cut, which accommodates the drawer bottom, and this radius on the top. There is no specific sequence to the cuts that we're making here, and in fact, once you've made the drawer sides and you've got the groove cut, you will have a right shoe and a left shoe. If we waited until we were done, we could cut this and it wouldn't be as big a problem. So keep those things in mind as you view the tape. Also, the position of this groove varies from one operation to the next. Typically, it's a 1/4 inch up, 1/4 inch wide, and a 1/4 inch deep. But certain drawer guiding systems are mounted under the drawer and may require more clearance under that drawer bottom. So check what kind of hardware you're using first. More information about the hardware can be found in my tape 102, Basic Drawer Construction. So you may want to take a look at that. All right, let's go ahead and I'll meet you at the router table and we'll start these cuts. We're set up here to cut the groove in the sides and front and back to accommodate the drawer bottom. This groove is usually about a 1/4 inch above the bottom and a 1/4 inch deep, 1/4 inch wide. So it's a 1/4 up, 1/4 wide, 1/4 deep, 1/4, 1/4, 1/4. This doesn't always work this way. Certain drawer guides will affect the position of that, so keep that in mind. Make sure that the drawer guide controls that. I've got a setup here so that everything's lined up. My stock's going to come in like so, and before I do that, before I make the cut, I've got one final setup. I've got to put a feather board on here to control the stock. So I'll set a piece of stock here about where I wish to be, bring my feather board in, get it roughly where it needs to be. Snug up my clamp a little bit, and then I'll put just a light tension on here, tighten that clamp up. And what that does, it allows those feathers to act like a holding device. You can hear them almost make that comb-like noise there when I'm done. So that's the holding position. One final check, make sure everything's locked securely. Good practice. Notice I'm still unplugged. I've got a push stick handy and ready to go. And I'll make this cut. Now, we've used the spiral bit because it'll pull the chips away from the cut, and because of the spiral orientation, it won't put as much shock on the wood. There are times that we actually cut plywood for drawer sides, and in that case we do want carbide because there's so much glue in here that that'll be a problem. Any other man-made or remanufactured wood product also requires a carbide bit. We'll see some other operations where we use tool steel, but I've got some stock here, a drawer front and a couple sides. Look your stock over. You'll want the best side, the best face, to be down or in so that you cut the groove on the inside of the drawer where all the beauty is. That's true with everything except the drawer front. With this drawer front we've got a bit of a knot here. I would want that down and in so that this best face shows on the front of the drawer. So as you look at that drawer front back here, you can see that it's pretty and all of the beautiful grain is out on the front. So what is a good practice is to stack your stock in the order that it ought to be before you make the cut. Having said that, I think I'm ready to go. Plug in my router. There's the groove cut using the spiral bit. You can see there's very few chips in here. Nothing's been impacted. The quality of the cut is really nice, and that's what's really important. So we've got our quarter across, quarter deep, and a quarter wide. Our drawer bottoms will slip into this. I didn't cut this front because this front's a little wide. It wasn't ripped to size. I'll get some stock and do that and have that ready for the rest of the joinery. But this gives you an idea of one of the easiest ways to cut the groove. We'll take a look at some other methods here in a bit. Here's a low-tech method of cutting grooves. We've got a router base that clamps in a workmate type device, and the router is suspended above it. In this case we've got a straight bit in here, and we'll feed in like so. The bit's rotation will push this against the fence, and we'll cut the same type of groove as we've cut before. You'll notice there's quite a bit much more chip buildup with this technique because of that straight bit. The spiral bit would have lifted it out and would be a better choice, but from the low-tech end, this is probably the least expensive way to go. One other thing I would mention, if we were going to do a drawer front now, we would have to change the orientation. We'd have to raise that bit up because the height of this would actually make the cut deeper into the face. Just the opposite of what happens when we do it on the router table. Now we're going to take a look at one last method of cutting that same groove using a router table and a little different technique. Here's the third method for cutting a groove in drawer sides and drawer fronts and backs. We're using a slotting bit, and the slotting bit allows us to move the piece or position the piece vertically like so, and the cut is horizontal. You can only see a portion of the bit, but this is what it looks like. There's a ball bearing back there, but we're not using the full depth, so it's hidden back there. We are just using a portion of the cutter, and we put a piece of thin paneling on here so that we limit the size of the opening. This reduces the amount of tear out when we make the cut, and it also reduces the chance that an end would dig in. So that's the technique. Now there's one thing that we'll add here, and that's a feather board. We won't put it down like this because that would put a pinching action on. Rather, we'll put a spacer under here and set it like so. Now, I'm going to do the drawer front, and I would do all of the fronts first, then I would do the sides. And the reason for that is the front's thicker than the sides. I'll have to reposition that feather board when I go to the sides. But for the sake of illustration, we'll do the front, and you'll know yet another way of setting up to cut the groove. I just lift this up above the cutter, test that, yep. Just a slight tension on there. So we're going to be able to hold our piece in, and we're also going to have a very difficult time of ever contacting the cutter. So let's get going. I think you'll agree that the quality of the cut is very good. The groove is smooth and true. It's a 1/4 inch wide, 1/4 inch deep, just as before. Now, you've seen 3 ways of cutting this groove. Ask yourself what those 3 are. If you can't, reverse the tape and take a look again. A radius on the top of a drawer side sure gives it a decorative effect. There are a number of ways of doing this, and we're going to explore it. And in fact, there are a number of styles. One is to go from end to end on a drawer side. Another is to make it a bullnose or a stopped method. That is, we leave the ends square. The square ends gives us a detail of the joint, yet gives us a finished professional look on the drawer sides. To make this, we'll use first this router table setup, and I'll show you a little bit about what we have here. First, the cutter is a half-round cutter, which gives a complete radius. This is the typical cutter that you may wish to use, although some people want a more graceful look, and you can see that this will give you more of a thumbnail or half moon crescent. So these are a couple of the cutters that are used for this technique. We've set the height for the center of our workpiece. There's quite a bit of bit exposed there, so we're going to add a little barrier or shield above this to keep our hands clear. And this is something you can make in your shop very easily, and I would urge you to do so. Make sure it's clear of the cutter. And I'll just use a couple clamps to position that securely. Check it. Yep, it's clear. Now, I'll use a push block to control my piece as I go through, and this will allow me to push it past and pull it out. So these are ready to go. I'll get my goggles on. I've got dust collection with this. Not all of the setups I've had have dust collection, and they've been quite a bit smaller. If you're doing this all day with any of these setups, a dust collector is the best practice. I cut the radius on plywood. There's just a slight flat on the top, and that's so that when I completed the cut over here, I wouldn't get a snipe. If I want to take the entire edge off, On the outfeed side here, I add a piece of 1/32 inch plastic laminate and then adjust the depth of cut for this side. When I come through, that will remove it and give me a joining effect. This is good enough. This gives us a nice radius across the top. On this plywood, it might take just a little bit of sanding. I'm pleased with what I have. Now I want to show you the method of making this bullnose or stop technique. In essence, what we have is a clamping technique, a stop at both ends. Two parallel clamps are used. In this case, we could use C-clamps with blocks of wood. We lock that down like so. Now, what we'll do here is we'll bring our piece in like so, let the cut begin, and then we'll feed down to here and pull it away like so, and that will give us our two stops on here. So let me fire up the dust collector and show you that technique. So now we have a stopped one. This is really ideal if you have a square type of joinery. You can cut the joinery and give you the decorative look that's necessary where two square pieces butt together. Well, that's the method that you'd use at a stationary setup using a router table. Now we'll take a look at a portable technique. We're using a laminate trimmer or a small router to cut the same type of radius. And I'll direct your attention to the other side of the bench for that. The portable router can also be used to cut radius on a drawer side. It might be a blind or a complete one. Right now I've got a roundover bit controlled by a ball bearing. The ball bearing will ride on the approximate center line of the board, and the roundover will cut 1/2 of the radius. The drawback to this technique, it takes two cuts. I'll have to flip this over and cut the other side. I put two pencil marks on here, and if I were going to make this a stopped radius cut, what I would do is bring the router in at those approximate points and back it off at the other end. This would give me a starting point and a stopping point. Now for this particular cut, I'm going to go all the way across. Make the cut on the opposite side. So that's all there is to radiusing. You've seen it both with the portable and the stationary setups. It doesn't matter. The situation is going to determine which method you select. Keep in mind that you can do it before or after. It's easier to do it before the drawer is assembled, a little more work after, but with the after approach you've got a second chance. That is, if you don't like the look, you can change it then. That's all there is to it. We'll move on to some other setups shortly. This drawer has one extra detail, a bead across the top and bottom. The neat thing about this bead is it makes the joint between the drawer and the face frame so much harder to see. That extra shadow line says where does the bead end and the drawer start, or where does the face frame start. This technique, little detail, little shadow, hides a big opening, and it's something you may want to do depending on what kind of gaps you have around your drawers. What I thought I'd do is show you the technique for making that bead real quickly here at the router table. I've installed a beading bit, which is a very small bit, and it has a ball bearing on it. That ball bearing lines up with the fence and controls the depth of cut. The bead is cut as this goes through like so. It catches that bead and makes the decorative cut you see there on the end. Now, there's really not a lot to this. It's just a matter of turning on the dust collection system and getting set up. So I'm going to do that real quick. That little bit of time that we took gives us so much more shadow and so much more detail that I think you'll agree that this setup is a very small, painless operation that adds to the beauty of your drawers and ought to be one you ought to consider. We're going to take a look at a drawer that uses what we call a tongue-dado joint. The tongue-dado joint is actually two cuts, a rabbet cut on the front and the back, and a groove cut at both ends of the side. Now, it may be a little more easily visible here because of the contrasting color. After that's done, we put a false front on the drawer that gives it the look of a 3/8 lip. That is, there's 3/8 all the way around here, and when we put it into the opening, there's a beautiful 3/8 lip so that the fit is perfect and the look is such that we hide any opening or any variation around there. Well, it allows us a little extra tolerance. To do this joint, we cut the grooves on the two ends of the two sides first and then the dados to match those. In most cases, we can do this at a router table. We're going to explore 2 or 3 ways of doing both the tongues and the dados, and we're going to go over to the router table now. I've got a drawer side prepared here. I'm going to show you how to cut the groove one way using a router table and a slotting bit. The first thing that we do is set the bit height equal to the thickness of the stock. That way, when the two pieces go together, they're flush at the front. Once that's done, we then position our piece vertically. Now, the depth of cut isn't that critical. It goes about to the center line of the workpiece. To control this, we'll use a push block like so. And to give us just a little bit more control and a little safety as a barrier between us and the cutter, we'll put this feather board up like so. Now, we'll use it to hold the stock vertically against the fence. And it also acts as a barrier so our fingers can't get near that cutter. I put a spacer under here so that the feather board will not touch the cutter. Now, we've got to remember that we want these two cuts on the inside face of the board, so we've got to remember to position it with the groove in toward the fence. We've got a nice clean groove, just a little deeper than the center line. We'll have to compensate on our drawer fronts if it's for whatever that tongue is. In other words, we'll have to add that to the length of our drawer front and back. This cut works very well this way. We get a very clean cut, nice and smooth. That's what we're looking for. We'll explore a couple other ways of cutting that dado or groove along there, and then we'll show you some ways of cutting the tongue. So I'll set up some other router tables and do that now. Here's a setup that allows you to cut the groove in a horizontal position. We've set this up already. We're using a straight 3/16 carbide bit. And one of the things that you'll have to remember here is you're going to the center line of your board, and we mark that. The other thing is the position of the fence is controlled by the thickness of the stock. The outer edge of that bit is flush with the thickness of your workpiece, or the side, I should say, of your drawer, which is the workpiece, 1/2 inch here, but it would vary in some cases, so you would set it for that position. This allows the mating piece to line up with the front. With any drawer side, we're going to cut the front and the back of it in one fell swoop. So I've got a piece of stock here, my drawer side that I cut my groove in, and I'm going to cut it like so and like so. Now, you might say, why not use a miter gauge for this? Well, if I use a miter gauge, then my fence has to be parallel to the miter slots. So what I'm going to use instead is a push block. This push block allows me to hold the stock against that fence and push through like so. Now you can see this has been chewed up a little bit already. That's part of what it's for. So I'll use that to make the cut, and then I'll show you what happens. As always, I've got everything set up with the power disconnected. Double check my settings, and then plug the machine in. Now what we're concerned with is that the front of the drawer side and the front of the false front or drawer front lines up evenly, as you see here. That's a good fit. This groove now will dictate the position of the rabbet that cuts to make that tongue. So that'll be the next setup, and we'll talk about that in the next scene. Earlier we cut the groove for the drawer bottom and this groove on the two ends at 3/16 to accommodate the front and the back. I'll set them on here like so to give you an idea how they'll fit together. The lengths have been set up to compensate for the joinery. Now, one thing that I like to do is mark these with a pencil line on the side where wood is to be removed, something like this. Nothing fancy, but by doing this, it eliminates the problem of getting over here and saying, which face should I put against the cutter? And there is a problem, because if we get the wrong side against there, we're back to square one, something that's nothing but pain in the woodworker's world. Having decided all of those things, we can position our stock, and we will add a feather board, again, to hold our stock in the right plane, keep it oriented against that cutter and against the fence. I'll just kind of snug that up, tighten that clamp. Okay, that should be just about dandy. Now, to control this stock, I'll use a push block, and all it is an L-shaped board, pair of boards put together. I've got my pencil line. I'll position it here. Looks like everything's a go. So let me fire up the collector. This is the fit we want. Flush with the front, the grooves, the tongues fill the dados, everything lines up. There's a bit of tear out on a couple of these pieces, and all you've got to do is just take one of these bench type abrasive deals, any type of abrasive, remove that, slip them together, and then you're ready for assembly. You'll have a drawer that looks something like this. There's your bottom, front, back, sides. And to this, if you're making a 3/8 overlay drawer, you'll add that false front or overlay. And that's what it takes to make the drawer up. We'll take a look at assembly just a little bit later. We're ready to cut the rabbet on the ends of this, and once again, I've marked the front piece or the back piece, whichever it would be, with a pencil line so that I'll remove that stock. We're going to take a different approach now. We're going to use a straight cutting bit, and we've set the fence so that only part of the bit is cutting, and we've adjusted the bit height. So this will actually ride along here. The guard will be in place, and I'll use a push block to cut this. And I'll set this up real quick and show you just the technique that we're going to use. Again, we've got to take a look at the front. We've got a little bit different thickness here. It's not a perfect lineup, but it's good enough for what we're doing. The joint fits well, and I'm happy with the setup. So I'll proceed to cut the back and the mating parts, and we're ready to glue up and actually show you how all these parts go together. So I'll meet you at the table here in a minute with the glue and clamps and show you just what the technique's going to be. See you there. Looks pretty neat out here right now, just the parts we need and everything laid out. That's the best way to glue up. I've got a brush so that I can brush the glue on. I'm going to set the parts in and work in a logical sequence. It's good to wet the joint, wet the wood with the glue to make the joint a good fit. Now these joints are fairly tight now, so they will really snug up once the glue's in. Very snug. Okay, now I can put my clamps on, just snug those up. And I get an idea how I'm doing. Got to rack this just a little bit. Much better. Okay. So I'm squared up, got it the way I want it. All I've got to do is allow the glue to cure up. When it gets a little leathery, I can scrape that off with a chisel, and then I can proceed to put on my false front to make it look like this overlay drawer we've got here. That's what the glue up takes, not much to it. We'll explore some other joinery next, show you some different ways of making drawer joinery. We're going to be making a joint that looks fairly complex, the dovetail joint, sometimes referred to as a dovetail dado because this is like a dado and this is like the tail. They slide together, make a very strong locking joint. In working with this joint, why do I like it? Well, there's a few things. First of all, it's strong. It's relatively easy to make as long as your stock is a 1/2 inch thick or thicker. The question is, why 1/2 inch? Well, the bottom of this dado is a 1/2 inch across, and if the stock isn't a 1/2 inch, then obviously it will not fill the dado. So that's the only thing that you really have to be concerned with, 1/2 inch or greater thickness. It's pretty easy to make. We're going to use a 1/2 inch dovetailing bit in a router table. Now, a few other things that of interest. This is the side, this is the side and this is the back. And they would slide together like so. You might say, how am I going to hold the back in? Well, the back can't be trapped in. It has to slide in from the back. So we'd actually slice the back off slightly so that this can go in like so. If you're using a flush drawer, and by a flush drawer, one that fits into the opening, you'll notice that there is room on the sides with this joint to allow room for the 1/2 inch side guide that ordinarily would be used with many of these types of drawers. Now, this will fit into the face frame flush with the front and still allow clearance. You couldn't use this joint with a 3/8 lip door or drawer. You couldn't use it with an overlay because these would be exposed outside. So a flush leaving a 1/2 inch allowance for guides will work. Well, the first step is to make this dado through the sides, and I've got a pair of sides that were prepared earlier with the grooves. Now, one of the things we have to do is remember that we have a right shoe and left shoe. That is, if we want dados back here at the back, we have to orient these pieces correctly when we get to the router table. Otherwise, we may have them flipped over like so. Now, if you haven't cut the groove, and you don't necessarily have to cut the groove first, it isn't as big a problem. So let's go to the table now, and I'll show you the setup and give you an idea what has to be done. To control our stock, we're going to use a miter gauge, and you may notice that I put a face on here. This face allows me to come through that bit. This is a backing face, so any tear out that might occur in the board actually occurs back here at the back of the backing board. So we don't have to worry so much about tear out when we make the cut. All right, so I've got everything set up. I've locked everything tightly. I'll check that one last time, prepare myself for the cut, and get my stock up here in position. Now, I've got to remember it's on the inside face and at the back, so I can start with this piece, snug it down. This gives me some clamping action, and I can make the cut. In this case, we got a little bit of tear out at the top. We could probably glue that down and tape it in position, and it would clean up fine. Many times it's better to make your drawer stock just a little wider than necessary. Then you can join or sand that off and get the desired size and not have to worry about the tear out. There will be a little fuzz on the inside, but that's not a problem. We can knock that off with some abrasives. Now, to make the mating part, I've got to decide where I need to be. Obviously, it's got to be back here, so I want to position this part carefully so that I know that this joint will be in the same position. I'll cut this mating piece, and then I'll show you how the two parts go together. We've cut the dovetail dado already in the bottom or on the sides. Now we've got to cut the mating part in the back. Let me tell you a little bit about what's changed. The setup's ready, and what we're going to do is this piece would be fed across here. It'd be a larger piece, of course. We have not changed the bit height. We have got a fence here now with a cutout because half of the bit is hidden behind here. When we bring this across, the cut will be such that nothing is taken off the point or front of the piece of wood because it's 1/2 inch thick and it is a 1/2 inch dovetail dado. As we cut both sides of this, then we will get this mating dovetail that goes together. Now, we're going to be using a push block like so to guide our piece across. This holds it perpendicular to the bit. You may notice that the fence is at a slight angle now. It's not nearly as critical. When we were making the mating part using the miter gauge, the fence has to be parallel to the miter slot. In this case, it does not. All right, so this push block will be used, and I've got my back here. This back will be cut on both sides so that it then fits the two drawer sides we cut earlier. So let me get set up now. A little piece of fuzz there. Try it the other way, see what happens. All right, it's very tight. That's a lot better than being loose, isn't it? What do we do about that? First, let's check the other end now and see how tight it is. This fits a little better, but it still starts to tighten up. And that'd be too tight for glue. So we've got to take just a little more material off, remembering that if we move that fence a little bit, we double that because we take both sides. So what I'm going to do is just tap that fence a little bit and see if that's enough movement. That's ideal. Okay, so now we've got everything set but the front, and that would be determined on what type of drawer we had, a flush, lip, or overlay. Now remember, if we're talking about one where we're going to have a flush drawer with a 1/2 inch side guides, we can make the same joint. We cut the same thing we cut on the side on the front, and then the front of the side gets the same cut that we cut on the back or on the two ends of the back. So that's the dovetail dado joint. I think you'll agree it is pretty easy after seeing the 3 steps that we follow through on it. So practice on your router table and let me know about your results. You've seen the dovetails cut on the router table, and I've got all the parts positioned here, and what I thought I'd do is share with you some techniques for gluing these up. You'll notice I've slid the joints halfway together, and the reason I've done that is that I don't want to glue the entire thing, but rather I want to glue half of it. The reason for that is, as these start to slide together, they're going to swell and heat a little bit. And if I tried to glue the entire thing, I'm afraid that they just may not come down and set. In other words, the glue joint could bottom out about there because of all the friction. The last thing in the world that I want at this point. I can already feel that thing tightening up as I squeeze it down into position. I've got it where I want it now, and I'm going to slide the back in. The back is going to help hold me square. And now, when I go to put the back in, the back is going to go in like so. And I'm going to slide it halfway down as well, just about there. And then I can put a little bit of glue in here, inside those dovetails, and then a little bit along the sides up here. Not much, just a little bit. And I'll do that on both ends. And then I'll push this down. Okay. Once I've got that lined up, I'll check to make sure I'm square. Ooh, nice. And then I'll set the drawer aside for it to cure. Now if I wanted to put a clamp on to pull that a little tighter there, I could do so, and maybe I will yet. Once that's set though, it's locked. So we'll just check for square. I'm good. I'm really pretty happy with it. As I sand that little bit of a line won't show. So I've got a nice tight fitting drawer. All the dovetails will be solid. Take a matter of about 20 minutes for them to set up. So I'm going to leave it alone, let it cure, and that's all there is to a dovetail glue up. The rabbet joint is one of the workhorses of the woodworking business, an easy joint to make and one that we can use on just about any type of drawer construction with success. I'm going to show you 2 or 3 ways that they can be made, give you some thinking, and then demonstrate some techniques. Basically, the rabbet joint has 2 components. If the drawer, there's a notch made, and the side remains the same. That is, it will butt in and make a joint like so. We've got the same type of joint here on this drawer. Notice the bottom is not attached, and I did that for a reason. We've got a rabbet joint here that's notched this way. Then on the back, the side is notched. Well, the joint is very sound. There's a lot of gluing area, but what we have in addition to that is some reinforcement on the side. We've got a couple nails in there to reinforce it. Now you could use wood dowels, you could use just about anything, but we've used some brads to reinforce that, and it gives us a very strong joint. One other thing you may have noticed is that the bottom of this drawer popped out. The reason for that is the entire bottom is a rabbet joint. This will fit in like so. With many of today's drawer guides, you'll find that they have an L-shaped bottom which just literally covers that joint. If they don't, there's no real problem. You've got a very large glue joint, a way of nailing this, and when the drawer is in operation, there's no vision of that. You won't even see that. It'll allow you to get a very tight fit because as you pull those nails down in the glue, you can see that the joint just about disappears. So those are some of the nice features of the rabbet joint. There are a number of ways of making that with a router table and with a router bit as well, but for the most part we'll do this with a router table. There's another technique. This is an overlay, and by that I mean we have a front that overlays the drawer. If you were making a 3/8 lip type, you might do this, and I've stuck this on with some double stick tape so that I could show you that this too has some components to it. We've got, first of all, the same rabbet configuration, and we'll take a look at how that's done in a bit. And we've got the same rabbet on the bottom. So these are some of the types of joints that you may wish to make. This drawer over here is exactly the same as this one is from the front, except we don't have those 2 beads. And we talked about the beading earlier, and that's just one extra operation. Well, that's an orientation into rabbet joinery. I'm going to get one of the router tables set up now to cut some rabbets, and we'll proceed with that here in a minute. I've set this up for rabbeting, and one of the things that we had to do is set 2 dimensions of the bit. First of all, from the fence, the bit extends slightly greater than the thickness of the drawer side. Then the height of the bit is such that it does not get into the bead that we cut on the drawer front. So those are the 2 dimensions. Now, there will be times that we use different dimensions. For example, this is a 3/8 lip front where we've cut a 3/8 lip all the way around. It's deeper on the sides than it is on the top and bottom so that we can accommodate a drawer side and have the same reveal all the way around. In other words, when we put this on, the dimensions here and here will be about the same. Now, one of the things that happens then is we're going to have to set this for the center line, and then we'd have to move the fence out. We would cut all the way around all 4 edges and then readjust to cut this to accommodate the drawer sides on the 2 ends. So that's some of the technique. Now, before I cut these rabbets, I want to share with you 2 or 3 ways that they can be done. One of the ways that we can do this is with a miter gauge, and I've got a backing board on here so that I won't have a tear out problem. I can position this and use this clamping mechanism to hold the piece and bring it through to make that cut. Now this doesn't always cooperate. Sometimes the guard wants to go up like so, but once we're set it will work well. Another technique we can use is to use a push block, and this push block allows me to just push through using a large thrust device that gives me my 90 degrees and controls the stock just like a miter gauge will. Another commercial device that will allow you to do essentially the same thing is this handler device. This handler device has a clear plastic piece here that goes against the fence. You then push your piece in until it butts against the fence. Now you've got the piece located correctly. Then it's a matter of feeding through like so. I'm going to cut one side with this, and then I will proceed to cut the opposite side with one of the other setups, and then later you'll see some others as we go through. Let me turn on the dust collector and we'll get started. Now let's check the fit. We've got just a little clearance on the side there, and that clearance then allows the drawer to fit. The front has been fit to the opening. Any fine tuning allows us just to trim that drawer front, not the entire side. So we can get a fine quality job by adding just a little bit on there. Always fit the drawer front first and it'll simplify the operation for you. Now I want to show you a totally rabbeted drawer, much like the one I showed you at the bench. I'm going to set up another router table and show you some of those techniques. So we'll get started with that here shortly. We've set up this router table to make this rabbeted drawer. This drawer has plywood sides and back and a solid wood front. In making this up, we're going to cut a rabbet on the ends of the sides and on both ends of the front, and all parts will have a rabbet on the bottom. This is the setup that we're working with right now, is this rabbet. And this was a scrap that I used to set it up, and you can see that I've got the height of the bit correct and the depth of cut correct. This will be the setup I'll use on all the parts. Now, what I've done is I've made one drawer side up. It's 3 feet long. The drawer is 12 inches deep and less than 12 wide. So here's the back and the two sides in one length. I've also got a piece of stock that I use for my front. All of these pieces need one cut on the lower edge. So we can look this over. We already know this is the front because it's been beaded, and we can decide if there is one side or another that would be better. And it looks like this one has some nicks in it, so I'll set it this way so when I pick it up I'll be rabbeting it like so. Look this piece over. I want the lighter side in, the darker side out, so I'll set that down in this fashion. So I know that's ready. Next I want to guard the operation, so I'm going to put a device on here to act as a barrier between me and the carbide tipped spiral bit that I've installed. And once I've done that, I can feed this through, and it's going to be very difficult for me to get my hands into that bit. So I've got the setups ready. Got a push stick here that I can use, a couple of them standing by. Get my goggles and muffs. There's a nice clean rabbet cut there, and the carbide tip spiral bit does that nice shearing cut we talked about earlier. I'm real pleased with what I have. Let's take a look at the plywood. Again, very nice cut. Any of you that have worked with plywood know that it is a problem with tear out. So we've really done a nice job here. Now, the next step is to cut the rabbets on the ends of the parts. And I've got another setup mark here, and I can proceed to do that. First, I'm going to have to remove my barrier so that I can see what I'm doing. And I'll just spin that bit around so I can see the cut. Loosen my fence. There's the rabbet cut. The depth remains the same, so there really aren't a lot of setups here. This fence is very convenient. It just pivots away, so I can go through like so and make this cut. Now, in this case, I'm going to be using a push block. You saw me use a miter gauge earlier, but since I'm not parallel to the miter slot, that won't work well. So I'll be using this push block, which means then I'll have to set this barrier up high enough so that the push block will clear. I'll just snug that up. I'll raise it just a bit. Bring it over, make sure I've got my clearance here. Okay, now the drawer front has to be done on both ends. And while I'm doing that, I will also do both ends of this piece, because these will be the ends of the drawer, and I'll explain what's happening in a minute. But we're set up to make the cuts, so let's do that. The depth of the rabbet has to be a little deeper for the front. It's exactly flush, which is as it should be. This plywood now, with the rabbets cut on both ends, will actually be used here, and then of course this would be the mate. You can see the rabbet back there. So the middle piece that we cut out will be this piece back in here. Now, since this isn't quite deep enough, and the reason it isn't, you want a little bit of reveal or overlay here so we don't have to trim anything but the drawer front if necessary. All I've got to do is leave everything set, but I've got to have a little more clearance. So all I can do is just put my piece there and move over. I can see just a little bit of clearance along there, which tells me almost the amount I've moved. I've got the fence secured now, and I can move that over. You heard that just little bump. That's the amount that I readjusted the fence for. Not a lot. So I'm ready to make the cut. Now I've got just a little bit of clearance there. If I wanted more, I could move the fence again. But I'm happy with that. Now all I've got to do is cut the sides to length, and the remaining material will be the back. So what I'm going to do is go to the saw, cut these parts out, and then we'll assemble them here in a little bit at the bench. So I'll meet you back there. We've got a couple of joints here that have two parts that are made with the same cutter. Kind of a unique way of making the joints. We've got two drawers that are already assembled that way, and what I thought I would do is spend a minute showing you how they work and what the nature of them is. As you look at these parts, they're oriented so the drawer sides are up, and these would be the drawer fronts. With this joint here, there is a profile that is exactly the same on both parts. They're complementary, and as you push them together, there's a wedging action. There's also a locking action so that if you try to pull these, just as you'd pull the drawer front, the sides will come along. This is made with a couple bits that you see here. One of them, the other. Both of these are the same. They cut the same types of profiles. This one has a 1/4 inch shank on it, and 1/4 inch is a little light for the types of feeds we're using. There's more deflection. I prefer a 1/2 inch because the 1/2 inch has more mass here and there's less deflection when you make the cut. So this is something you may want to look at when you decide on those bits. Now let's take a look at another joint, quite similar. Both parts are made the same way. This is called a glue joint, and you may have glued two boards together edge to edge with this joint, with this cutter, using this particular profile. You can also use this to make a joint between two parts. It cuts exactly the mirror image of itself, and as you push them together, there again is the wedging action, and also there is that resistance as you pull them apart. So the front or the side will follow the front as you pull the drawer open. That was cut with this bit here. This is just a little bit different. It's got kind of a V shape to it, and the V sides allow it to wedge as you clamp it up. So those are the cutters that are used. This is what the joint looks like. There are some differences, and I'll just point those out on the drawers. Notice that typically the drawer front is a little thicker than the back. And so what happens is the joint here is a little different than the one at the front, and we may have to make some adjustments to bit height and so forth when we make this. And that just depends on what the thicknesses are, and there'll be some setup testing that you'll have to do. The same holds true here. We've got a little bit of a difference between the two. It's not a big problem, but we do want to make sure we have at least a tongue and groove joint there, at least one complete one, or we really don't get a lot of strength. All right, that gives you a little bit of an orientation as to what these two are like. Remember, one bit cuts both parts, kind of a unique aspect to it. A very convenient way of making drawer joinery. You can make this with an overlay front as well, either one of these, so you're not limited to one particular setup. All right, with that in mind, I'm going to go ahead and cut both of these at router tables, and then when we're done with that, we'll come back here and glue those up so you can see how these drawer parts fit together after they're cut. So I'll meet you at the router table, and we'll go ahead and start cutting these up. We've set the drawer corner up, and we've got the position just right for what we want to do. We've set it at about the center line of the 3/4 inch drawer front, which would be perfect if you're going to make a 3/8 lip drawer. When you take a look at this setup, the mating part is going to come across like this. So once the setup is made, both parts are actually cut with the same setup. It's a complementary cut, so the height doesn't matter that much. Once it's set, you leave it for both of them. Now, if you were making a 3/8 lip drawer, you're going to move in further. That is, the fence will have to be moved over. So you might make that cut first and then move the fence over to make another cut to get that 3/8 lip type of orientation you would have right here. So there's just one extra step, is to move that fence over. There's nothing to it. I've got my height, so the next step would be to set up, and I've decided that I'll do my drawer sides first, and I'll look it over, decide which side I want in, and then I'm going to again use the feather board to act as a barrier, keep my hands away from the cutter, and I'll just set it up like so I get an idea of about where I need to be. Move the block, position, something like that. And I'm set. So I'll be using this as a feeding block to feed that through. There's the cuts. Now, a couple simple adjustments and I'm ready to cut the mating part. So let me take off my feather board now, and I would cut all the drawer sides at one time, obviously. And I've got a piece of stock prepared to be my drawer front. Again, I'll look it over. This is going to be the back. I got my sanded side up, and I'm going to do a couple things to make this a little safer as well. Again, I'm going to put this barrier up above, and I'm going to use the push block to control the feed. I left it just a little high so my push block will go through. And this will be the approach I'll use here. So once again, the setups do not take very long. It's just a matter of changing your pushing device. Once again, I got just a little bit of tear out. What's happening is my backing board has gotten chewed up a little bit. If I were to saw that off, I'd have a new solid area and that wouldn't be a problem. I could eliminate that very easily. Okay, there's my fit. I'm real happy with what I have. Nice tight fit. The outside aligns perfectly. There's just a feather of space there, and that's ideal. That gives me a little clearance. If I wasn't happy with the clearance, what would I do? You know, just move the fence back just a little bit, and I could make that deeper. Again, if I want to make the 3/8 lip joint, all I do is move the fence back until I have my 3/8 lip on the outer edge. That's all there is to it. Well, you've seen the setups. I'm going to get ready. I'm going to cut 2 or 3 drawers, and then I'm going to come back here, glue them up at the bench. So I'll show you that here in a little bit. The glue joint cutter is a little bit different than the drawer joint cutter, and the difference is that while there is only one setup of the bit, we have to move the fence for the various parts. The depth of cut here is just slightly greater than the thickness of the drawer side. That's all you remove. That way the drawer side is held inside the drawer front. Now if you're going to make an overlay, you could move it in, but unfortunately if it was a 3/8, it doesn't line up very well, so it's better as a flush drawer. Now, the mating part then requires a readjustment here, and we'll talk about that in a minute when we do that. But I am set up to make this cut, and I'm going to put my barrier in position again, and we'll make the cut, and then we'll proceed to make the drawer side cut. Look my piece of stock over, decide which is the better side. The good face would be up here. Okay, the cut looks pretty good to me. I'm pretty happy with that. I'm going to take the barrier guard off. And I'll set up the mating cut. Now once again, the depth of cut will be just slightly greater than those grooves. I've locked that down, and I just double check. I'll bring that cutter out just a little further and say, feels pretty close. All right, so there may be some trial and error when you do this, so take a test pass on a scrap to see what the fit's going to be like. I've got a push block again that I'll use, and I haven't even cut it, so I don't have to worry about tear out here. Now, in looking at this, I'll select the good face in, and this is about what I want. Now what I want to do is put my feather board in position, and again a block of wood so I'm not trapping the cutter, but rather I'm well above that. All right, so I've got everything ready to go the way I want to do it. Once again, I've got a nice fit. There's a wedging action. As I tighten that clamp, that will pull in beautifully. So I'm pleased with what I've got here. There's a little fuzz, but we can knock that off and we're ready to go. So these are the two steps. I've got my height set. All I'm going to do now is cut my parts, make up a drawer, and then I'll meet you at the bench to show you the wedging action when we glue and clamp that up. So I'll see you there to do some glue up. This flush drawer has the drawer corner joint, and I want to call your attention to a couple things. At the back it's a little different than it is at the front. That's because the front is a little thicker than the back. This is a flush drawer, and as you pull the clamps together, I think you can see by the inclined sides of this, you get a wedging action. That's really a benefit for you as you glue the joint up. And we're going to glue this drawer up. I've got everything set up here. And it's just a matter of applying glue and putting the parts together. All the sanding has been done already on the inside. Let's do this. Let's get both ends of this. That will allow me to set it up something like this. And this. Bottom in. Put a layer of glue both ends. I'm going to just lay it down like so. Put a clamp up close, and I'm going to be careful. I've got a little bit of a lip so that the drawer front is actually a little bigger than the drawer. And just get an idea what I've got to do to bring this into square. There we have it. That into alignment. You can see that wedging action as I tighten those clamps. It pulls the parts together just beautifully. Check my square once again. Looking pretty good. I'll flip it over. Put a pair on the opposite side. Not too much pressure, but you do want to pull the parts together. Okay, sitting square, leave it alone, let the glue do its job, and we pull the clamps off. Whenever you do a job like this, it may be better to put some clamp pads on, but I haven't clamped this real tightly. I don't want to smash this. I just want to pull the joint together and let the wedging action do its work. If you're going to really muscle down on the clamps, put some pads in there though. Well, you've seen the glue joint cut on the drawer front and the drawer sides. And once again, you've got a wedging action here. And what I thought I'd show you is just how that works. As these two parts go together, there is a joint formed, and as I put clamping pressure this way and this way, there's going to be a wedge, and it'll pull that very tight. Adding the glue to that, we're going to have a lot of strength. Moreover, as you start to pull the front of the drawer, the side has to come along because they're locked together. That's the beauty of this joint. I've got the parts laid out here. It may not look too neat, but it's a way that'll work for me. So let me move this out of the way and proceed to put my parts together. Once again, I'll use glue and I'll brush it on pretty liberally because part of this is end grain here, and as you well know, end grain just isn't that strong. So we want to get that glued nicely, both ends. The inclined sides actually make it more like face grain though. I'm going to set the bottom in here because there's just a little twist in it and it'll stay by itself. Pull this over to the side here so I can push these two parts together like so. There's the back. Wedging action's pushing the glue out. I was just a bit too liberal there. Okay, so now I'll bring it down, set it down like so, take a look at it and just get an idea where I am. There, that's nice and square. Put my clamp on and see what happens again. Tap this lightly, bring it down flush. Yep, we can see that glue squeezing out of there. I don't have just barely hand pressure on there. That's all you really need because this joint wedges together. It doesn't take a Charles Atlas hand, just a gentle touch, and they'll wedge together. Now I'm holding square real nicely, and I just want to bring you this corner and show it to you. Look how nice that's tightened up there. Can you see that? That's what we're looking for. And we'll flip it over now, put the other pair of clamps on, double check for square, and I think we're ready to leave it lay until the just snug them up. One hand's enough. Very nice. Just lift that up. Good and square. Okay, from there I'm just going to leave it alone. That glue will set up in probably 20 minutes to a half hour. There's not a lot of stress on it. I can pull it off and proceed to work on any other fitting element I need to consider. So that's it for that glue up. Good luck in woodworking. We'll see you later. It's good to have a storage place for those expensive bits when they're not in use. In fact, that's kind of why we've made up that nice base in the router table. If you've been admiring these during the course of the video, we'd like to tell you about a set of plans that are available for these. Many of my friends and students like this as well. They asked about the plans, and so we developed a set that are available now. There are 5 pages of prints here and a lot of options that you can use no matter what type of router table you'd like to make up. And there's plenty of opportunities to try your router skills in making this up.